What's up everyone, Patrick here, welcome back. Moving on to the next example on the Unit 1 Advanced Functions test. So we are given a bunch of characteristics for a function and we have to sketch the function that's going to match these characteristics. So let's get into it. We got this list here, let's go through it. As usual, I recommend pausing the video at this point and try to sketch a function that is going to match these characteristics. And it doesn't necessarily have to be the same as mine, the same as the one I'm going to sketch. There's an infinite amount of graphs you can make for these types of questions. But I'm going to take you through my thought process when I get a question like this. First thing I always like to start with is any characteristics where there is no subjectivity involved. And so the first thing that includes is points. So notice here we're told f of 0 is equal to -4. So we know that the y-intercept is -4 here, right? This point here is 0 and -4. I'm just going to write -4 to save some room. And then over here, we got f of -3 is equal to 0. So f of -3 equaling 0, that's like the x-intercept, right? This point is like -3 and 0 like that. I'm going to just write -3. Okay, so these are taken care of, right? There's no flexibility on where we could graph these because they're concrete points on the graph. Next, vertical asymptote at 3. So again, not too much flexibility there. Vertical asymptote is a fairly concrete characteristic, so I'm going to just draw a dotted line there. And now these other characteristics, we have a little bit more flexibility. So notice here we're told as x approaches -infinity, meaning that the left hand behavior, as x approaches -infinity, y approaches 2. So just from that alone, we could tell that there's a horizontal asymptote at 2, right? So as x approaches -infinity, we're either going to approach this y value of 2 either from the bottom or from the top. So that's what I mean by some of these characteristics we have more flexibility. But in this case, hopefully you could see, because it has to go through these points, it's more likely that we're going to be approaching this y value of 2 from the bottom, right? And then it's going to go through these points. But we're going to have to look at these other two characteristics as well. But nevertheless, this here, this characteristic here, hopefully you could recognize that this represents a horizontal asymptote. So if you ever see as x approaches -infinity or +infinity, and then y approaches a certain number, then you know it's a horizontal asymptote. If you had something like as x approaches -infinity, y approaches +infinity, the function would be going that way. Or as x approaches -infinity, y approaches -infinity as well, function would be going that way, right? Or as x approaches +infinity, right? If we're going this way to the right and y approaches +infinity, it would be going that way. But in this specific case, since we are approaching a certain number, right? The y value is approaching a certain number, we got a horizontal asymptote there. All right, now notice we're not given as x approaches +infinity, so we don't really know what's happening on this side. Maybe we could make an asymptote if we wanted to. It could go up here, it could go down here. We'll see when we look at these characteristics. Now, notice this next characteristic says the function is decreasing on the interval from -infinity to 3. So remember, whenever you get an interval like this, it's always in terms of the x values. So from -infinity to x equals 3, so basically to the vertical asymptote, the function is decreasing, which means that the y, as you read from left to right, the y values are going down on the function, right? So a decreasing function can look like this. It can look like this. Basically, as you read from left to right, the y values are decreasing. Okay, and as I mentioned, that makes sense with the characteristics that we have here, because we know that it has to go through -3 and -4. So it makes sense that this function is going to be decreasing. All right, so I'm going to actually draw this function in a different color. So we got this part right here approaching 2. It's got to go through 3. It's got to go through -4, and then it approaches that vertical asymptote. We're going to make it go down to -infinity. Right, so you can make this more like a curve maybe on your paper. This is not the nicest graph, but nevertheless, it does satisfy these characteristics because the function is decreasing, right? The y values are going down as you read from left to right. It's going through the x-intercept of -3 and the y-intercept of -4, and then as x is approaching -infinity, we're approaching that y value of 2, like that. And then notice that on this side here, we're given a lot of flexibility. We're just told that the function has to keep increasing, right? From 3 to positive infinity. So on this side, the function has to keep increasing. So we can maybe draw something like that, right? So the function will keep just going up and up like that. Now, technically, we could also make like a horizontal asymptote here, wherever. We can make it down here. We can make it at 0 even. Like, let's pretend we made it at 0. We could even make a function like this, because what would happen here is that it would never touch this axis, but it does keep increasing forever, right? So the y values are increasing as we read from left to right. So that's another possibility. You can make an asymptote if you want. On that right side, we got a lot of flexibility there. I'm probably just going to make the function go like that. I'll make it increase to y value of positive infinity as x approaches positive infinity. All right, so again, different ways you can graph these. On this left side, I feel like there was less flexibility, so hopefully your graph did look something like this. On that right side, there is a little bit more flexibility. Nevertheless, this graph does satisfy all the characteristics. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.